Hi everyone, I'm Yun-Wei. Today I'll talk about analysis on meta-weight network for label-disturbed issues. Current image classification models tend to overfit when the dataset is noisy. So meta-learning-based sample reweighting strategies commonly used to solve this issue by designing a weighting function mapping from training loss to sample weight. But current reweighting methods need to manually define the weighting function. So to address this issue, the paper proposed a method that dynamically learns weighting functions from the unbiased metadata. The problem settings in this paper are corrupted labels and imbalanced labels. The corrupted label issue means the label of each image is changed into a random class. And the imbalanced label problem means the image's distribution per class is not identical. For the implementation, I first worked on rerunning the code from the original paper, but I'm not able to successfully run their code due to the mismatch of the software versions or errors in their code. So I had to debug the code and rewrote a portion of it to make sure that it works. I also rewrote the training and testing part and implemented a multi-layer perceptron to weight the training process dynamically. For the image classification model, the author used ResNet implemented by Adrian, so I followed their instruction and used the provided ResNet. The dataset is CFAR10 with an 80-20 splitting for model learning. In their paper, they did not consider the complete setting in terms of the design of dynamic weighting function or different label disturbed factors. So I did some additional experiments for discussing the performance of the proposed method. Here's the overall framework. We first took a portion of data from a clean metadata set and passed it through the model. The loss then input to the dynamic weighting function to learn a weight that reflects the clean distribution. During model training, the model took the data from the noisy training set and used the weight to update the loss. In the first corrupted label experiment, we considered two different settings, which are meta-function designs and the corruption probability. For all the experiments, we perform learning rate decay at 80 epoch. So the tables record the maximum testing accuracy before and after the learning rate tuning. From both tables, we can see that the performance of the models can be boosted after learning rate tuning. And after being fully trained, the model can adapt to different corruption probabilities and generate great results. As you can see from the tables, the original paper did not do complete experiments, so some cells in the tables are left blank. The right figures are training loss and testing accuracy during learning. We can see that the testing accuracy fluctuates before the learning rate tuning, and the training loss drops dramatically after tuning. This all shows that the method is sensitive to hyperparameters, and the model tends to be stuck in local minimum before the tuning. Here are the results of the second experiment, that is, imbalanced label experiment. The results also shows the model is sensitive to hyperparameters. But with careful designs, the model can reach 90% accuracy even with higher imbalance vector, showing the strength of the method. And comparing with the previous experiment, the model seems to perform well and stable at this noise setting. So overall, the author's method can solve label disturbed issues in image classification task, but we first found that this paper lacked detailed experiments and discussion on models and noise settings. And during the experiment implementation, we found that the method is sensitive to hyperparameters, resulting in unstable testing accuracy, although the maximum accuracy of the model can reach good results. But searching the optimal parameters would require an extreme computational cost. So some research work also found the instability caused by meta-learning, hence trying to stabilize the method. So I think the urgent future work of this project would be stabilize the learning process and improve the performance. Thanks.